A warm welcome to everyone. Thank you everyone for supporting me in listening to my video lecture series. As a part of it, in today's video lecture series, I am here to present on the topic Mechanical Compaction Method of Ground Improvement. Before going to Mechanical Compaction Method, I am here to explain what is compaction. Actually, what is compaction? Compaction is the method of expulsion of air voids from the soil by applying static or dynamic load so that the volume of soil is completely decreased, thereby increasing the strength and stability of the soil. In the process of compaction, we have to add water content so that the soil becomes more firm, and also the air voids present inside the soil can be reduced to the maximum extent by applying mechanical energy. Mechanical compaction is a process or a simple ground improvement technique where the soil is densified through external compactive effort. So we are applying external energy to the soil particles along with water so that the soil rearranges to a densely packed media. The process of compaction of soil involves expulsion of air voids from the soil, and also it is used to reduce the settlement to a considerable extent, and also it increases the stability of slopes. The areas where soil compaction or mechanical compaction is involved is highway, railway embankments, earthen dams, various multi-story buildings, etc. These are all the areas where mechanical compaction is involved. Mostly it is used for road construction. The various advantages of mechanical compaction are as follows. It increases the shear strength characteristics of soil by improving the density of the soil. If the density of the soil gets improved, other properties such as shear strength, permeability, etc., and also bearing capacity of the soil can be greatly improved. It also reduces the compressibility or settlement of the soil. It reduces permeability of the soil so that there won't be seepage of water inside the soil mass, and thereby the percolation of water can greatly be reduced. It also reduces the liquefaction potential of the soil. So what is liquefaction? Liquefaction is a process of loss in shear strength of the soil due to vibrations or shocks which is subjected to the soil mass in case of natural calamity such as earthquake. Next thing is it controls swelling and shrinking of soil. While you consider a clay soil, on addition of water, there will be huge expansion, that is swelling of soil. Where on the other hand, where there is no moisture content present, the clay soil shrinks or decreases in volume to a greater extent. So these two properties can be hugely minimized upon compaction. It also prolongs durability of the subgrade soil media so that it can withstand heavy amount of loading for a greater life period. The strategies involved in the compaction process are: in case of constructed fields, specific placement conditions such as water content, density and depth of layers to be considered. We have to select appropriate equipment such as roller compactor, tamping rod, and the method of operation such as number of passes, patterns of tamping, etc. We should also set up adequate control procedures such as type and number of tests involved, statistical evaluation, etc. to make the process of compaction more effective and more advantageous. The process of compaction involves the obtain of compaction curve and define the maximum water content, that is the optimum moisture content, corresponding to which maximum dry density can be achieved for a specific compactive effect. There are two different methods of compaction. One is standard method and the other is modified method. In standard method, we compact the soil in 3 layers and each layer is given 25 blows and a weight of 2.7 kilograms of hammer is dropped from a height of 300 mm. The volume of compaction mold used is 1000 ml or 1000 centimeter cube. Whereas in modified Proctor test, 5 layers of soil is compacted and each layer is given 25 blows and the weight of hammer differs. The weight is 4.9 kilograms and height of fall is 450 mm drop free fall. So this is a typical compaction curve where we can observe the increase in dry density to a certain extent upon addition of water. The maximum dry density is achieved at a particular water content, that is optimum moisture content. If you compare standard Proctor test and modified Proctor test, a lesser amount of water content is required to achieve maximum dry density in modified test. Why? Because more amount of compactive energy is involved and lesser amount of water content is thereby needed in case of modified test. Whereas in standard Proctor test, more amount of water content is involved to achieve the same maximum dry density. Because we are using 2.5 kilogram rammer instead of 4.7 kilogram rammer where we used in modified Proctor test. So the amount of compactive energy used for compaction is calculated using the formula number of blows into number of layers into weight of hammer into height of fall to the ratio of volume of the mold. So the compactive energy released in standard Proctor test is 563 kilonewtons per meter square, whereas 2530 kilonewton per meter square in case of modified Proctor test. So these are all the various instruments used in compaction. This is sheet foot rollers where the tire is given with an impression of sheet foot, that is used for better compaction. Next one, we are more familiar with roller compaction where steel drums are used in roller compaction. Next equipment is rubber tire roller. Next is dynamic roller compaction equipment. Next is dynamic compaction by means of vibro compaction. Next is rapid dynamic compaction equipment. So there are various factors affecting the compaction of soil. These are listed below: the type of soil, moisture content, compactive effort, method of compaction, degree of saturation, and presence of organic matter inside the soil mass. Thank you for listening to this video. Keep supporting. Have a good day.